This is day 4 of our Unit 4, Section 2. It is part of probability, geometric probability. So the first thing we'll talk about is that probability is just, in general, the likelihood that an event will occur. So for all probability, it's the desired outcome out of all possible outcomes. So if we just started and looked at this in a bag of Skittles, there are 14 green, 14 purple, 10 red, 12 orange, and 10 yellow. What is the probability you select an orange Skittle? So we want the orange out of the total. So the orange Skittles was 12, and the total Skittles would have been 14 plus 14, 28, plus 10, 38, plus 12, 50, plus 10, 60. So 12 over 60 reduces to 1/5. So the probability that you select an orange Skittle would be 1/5. So assuming that we have all of these same reasons, you are going to try what would be the probability to select a red Skittle. You can pause. Answers are posted on the blank notes in Google Classroom. So now we'll specifically talk about geometric probability. So that's the area or the length desired over the entire area or length. So if I wanted to know the probability that if a point were placed on all of segment AF, would it be within the specified segment? So we do need to know how long the entire thing is. So we went from -15 to 21. So if I did 21 minus -15, the total is 36. So for each of these, it would be the length of that segment out of 36. So for AB, between -15 and -9 is 6 spaces. So that would be 6 out of 36. And that reduces to 1/6. For CD, that goes from -3 to 6. So that's a total of 9 spaces out of the 36. So that reduces to 1/4. For BE, we're going from -9 to 18. So that's a total of 27 spaces out of the 36. That's 3/4. And for DF, that went from 6 to 21. So that was 15 spaces. And 15 out of 36 is the only one that's going to be a little weirder, 5/12. And by a little weirder, I mean not as easily reduced. So for these, it's perfectly fine to leave our probability as a fraction. So in try 2, you're going to do just that. Find the probability that if a point were placed on LQ, it would be within the specified segment. You can pause. Answers are posted at the end of the blank notes on Google Classroom. The more common geometric probability problems we'll do is find the probability that it lands within a specific area that they're asking for. So in this one, it's the shaded region. So we're going to have to be doing the shaded region divided by the entire shape. So the shaded region here is our big circle minus our small circle, and the whole thing was the big circle. So that's how we're going to find our geometric probability for this one. So the big circle had a radius of 4. So the big circle, the area would be pi times 4 squared. And that's 16 pi. I'm going to leave it exact for as long as I can. The small circle has a radius of only 2. So it's going to be pi times 2 squared, which is 4 pi. So that means to get the big minus the small, the shaded region would be 16 pi minus 4 pi, which is 12 pi. So that is going to be my desired area. And we're going to divide it by the whole thing, which was the big circle, which was 16 pi. So what's really nice here is for an exact answer, we can reduce, we can get rid of the pi's, and now it's just 12/16, which is 3/4. So that I can write as an exact answer. Sometimes, especially if we're dealing with squares and circles and things like that, it's just easier to turn it into a percentage. So 3/4 would have been 75%. So in try 3, you will likely have to turn things into decimals because we're dealing with a square and a circle. So it's fine to leave your answer as a percentage. So for this one, your answer is on the blank notes in Google Classroom. You can pause and try this now. All right, so in example 4, find the probability that a dart would land in the shaded region. So exactly the same as the last ones. It's just that this one now has a polygon inside, which means we have to do our 1/2 mass. And because we have to find the radius of the circle, we will have to find the radius in that little triangle that we made. So I'm going to start with the polygon stuff. N equals, A equals, S equals. We know we have 5 sides. And the 12 is showing us the length of a side. When we make our right triangle, we know we're going to have to find R. We're going to have to find A. And because I know S is 12, the bottom of the triangle is half of S. So that's 6. And my angle is 360 over double the number of sides. So 360 over 10 is 36 degrees. So to find the apothem, we're going to do tangent. So tan 36 equals 6 over A. This will be division. So 6 divided by tangent of 36. And we get 8.26. So I can already find the area of the polygon. All right, so we do 0.5 times 5 times 8.26 times 12. We get 247.8. We're going to change our screen a little bit here so I can get longer. All right, now we're going to find the radius so we can find the area of the circle. So that's going to be O and H. That's sine of 36 equals O over H, 6 over R. It's going to be another division problem. We're going to do 6 divided by the sine of 36. We get 10.21. So for our circle, when we do pi r squared, I'm actually going to keep that number in my calculator still, square it, and then times it by pi. So the circle's area is 327.35. So now, shaded region would be circle minus polygon. So the shaded region is going to be 327.35 minus 247.8. So my shaded part is 79.55. And now we're going to take, for the probability, the shaded over the whole thing. The whole thing was the full circle. So when we divide this, we're going to get a decimal, 0.243, and multiplying that decimal by 100 gives me my percentage. So that would be about 24.3%. All right, there's one final one for you to try. I just want to make some notes for you here before you try it. This here is the distance from the center to the middle of the edge. So this would be the length of the apothem. 8 is the length of the sides. And because this would also be an apothem the other way, this would be another 6.9 going here. So for our triangle, we now know our full height, and we already knew the full length of this side. So there's not even any trick to doing this problem because you have A, you have S, you have N for your polygon, you have the full height, and you have the base for the triangle. So you can give this one a shot. Answers are posted on Google Classroom in the blank notes. And that is geometric probability.